Okay, thanks for joining. So, who is a developer? Okay, some at least. So otherwise we could have directly gone. Yeah, so starting with us, maybe Phil, you can start.
Yeah, hi everybody, I'm Philip. I'm working in my spare time at White Duck. In my main time, I'm a husband and father. And with me, I have Nico.
Yeah, Nico, I'm head of platform engineering, cloud solution architect. So basically helping our customers to get their stuff somehow running mainly in the Azure cloud. Yeah, the idea for the next 30-ish, 40, 45 minutes? No. It's basically to talk about security, tada. So it's still important to talk about it. So it's still important to raise awareness. And the idea of this talk is, so we had the similar talks the years before, and we mainly talked about operating it, talking about runtime security and the Kubernetes cluster with containers. And now we thought, okay, let's shift to the developer side. So showing you some best practices, some nice integrations, how to integrate security into a developer lifecycle without bothering any people, and to make it a little bit easier. This is basically the idea. We are quickly talking about some basics, and then we're doing a hands-on demo, and hopefully it will work. I think this is something basically everyone talked about today, so quickly summing up that one. Though the idea is to really think about DevSecOps, which basically means integrate security into every stage of the DevOps process. So not about, okay, let's implementing a feature or a whole product, bringing it to the dev stage, to test stage, nearly before production, asking the security guy, hey, we would like to launch something tomorrow, is everything fine? And then basically there's a full stop, all the security stuff is starting, and basically, yeah, I get rid of all the deadlines and times I thought about. So the idea is to really integrate it in the whole process, and really starting at the beginning, which basically means starting here. And when you plan a feature, a functionality, really also think about what this means in regards to security, and really think about security from the beginning, and then starting implementing your function, including security, building it, testing it, releasing it, and so on. So in every stage, thinking about security, think about it early, and this is basically the second part, shift left. So shifting the whole security part to the beginning, to the early stage as possible. And this is not only about security, it's basically about everything. But in this concept, we're talking about security here. So you get a faster feedback loop. You know when you have any issues, you can fix it directly. You're improving the overall quality in the whole process, and you get also fewer production issues, which is, I guess, a good thing. So everything we were showing today has this pattern in mind, integrating DevSecOps in the whole lifecycle and trying to shift left and to provide feedback to a developer with security best practices and feedback as early as possible. This is basically what the talk in the next minutes will be about. So, demo. And basically nearly all of the slides are nearly done. We have two demos we would like to show. The first one is basically focusing on the awareness part. So we have built a small application, I will show you in a bit, with some dependencies, also some vulnerabilities, and we'll show you how you can get awareness with different tools, getting awareness of your dependencies, maybe of the dependencies of your dependencies, and so on. We'll talk about software bill of material, short SBOM, and show you how those can also help you to gain further awareness. So this will be the first demo. I will do that one. And then Phil will continue with the second one. And this is really about fixing vulnerabilities in container images, as well as then, also signing and publish images so that you can make sure that the image you have built and shipped to somebody, that somebody can really validate that this image is from you, that is really signed. So this is the second part. So you will find everything, the demo, the slides, and all the stuff on GitHub. So we basically will do the most part of the demo also in GitHub directly in this repo. So you will find all the stuff there. We will showcase you some tools. It's just a selection for us. So really make sure the ideas are right ones. If the tools are the right ones for you, you have to decide. So there are multiple tools out there doing nearly the same things with a little bit different integration and feature sets and so on. So please check all the CNCF landscape open source tools, which tools fits really your needs, and start implementing those. It's just a small kind of tools or a small subset of tools we're showing you today. So, and with this, I guess, yeah, it's demo time. Now this is the repo we already showed you. It's basically nothing important in here. It's just, it's a .NET application. It's an API. So quickly spin up code spaces here to show you the application. Really nothing fancy at all. Okay. It's a little bit slow today. So, as I said, it's just basically one endpoint doing a weather forecast here. We have two dependencies, one being OpenAI. We will focus on the OpenAPI, sorry, we will focus on that one today. So it's not really much dependency here. It's just two dependencies, and everything we are doing is a .NET Run is just exposing a Swagger interface with the / weather forecast API here. So really nothing special. So if we do / Swagger, we're seeing we're getting an API, get weather forecast, can try it out, getting some sample data here. So nothing fancy, just one endpoint. It's enough for this example, just to get you an overview of the application itself. So, first thing we will have here, and this is really, as I said, just one tool. In this case, we relied on DependerBot, which is a tool integrated in GitHub, but there are also tools like Renovate. I think some talks already mentioned it. So basically, this helps you to make the awareness of your dependencies. In this case, we have 4 pull requests opened directly by DependerBot. The first one are the 2 dependencies I showed you some seconds ago, and they're saying, hey, you can update them. We will pick one pretty soon, and the second one are related to our Docker file. So it's basically a multi-stage Docker file. It's the SDK and then the runtime for execution. So this is the first step. You're getting proactively feedback. Hey, there's a new version. Might not be any security issue in case, but hey, think about testing it, validating it, and yeah, updating it. So we just go for the OpenAPI one here. Doesn't matter. First thing, and this is also same with Renovate, for example, you're getting all the information, you're getting the release notes, you can also check the details here, and which is really important and I would like to focus on is the pipelines we're running here. So we have built pipelines, multiple vaults, to directly validate if our application running with the new dependency, if everything is fine. So we're building it, we're testing it, we're also doing code signing here, for example. So this one here and the last one, doing static code analysis on the code to validate if you have any big issues in the code. Now with the DependerBot PR, might not be the case, but if I implement a new feature, bringing in new code, we're getting really an early feedback, hey, there's something completely wrong in your code, for example. So this would go on red, and you would have some integrations in GitHub providing you with more details, why this is a bad idea, how to fix it, and stuff like this. So first thing is our code is at least somehow good. Second one is our build and release pipeline. I'm going to the summary here. So we have multiple stages. It's just preparing, getting all the things we need. Then we have the build and Docker build we will focus on now. And this is skipped in pull request. This is what Phil will talk about later. The important part is the Docker build here. And maybe go quickly to the code to show you what's going on here. In this case, it's GitHub Actions, but once again, just one tool. So the important part here, we're doing many stuff. We're doing a Dockerfile lint, for example, to make sure that also the Dockerfile is safe. We're building the Dockerfile. I think this is nothing we need to talk about. The important parts are those here, with those above here. So we're using still one tool, Trivi from Aqua, a security open source tool, to validate all our dependencies, because you will see in a sec, we have much more dependencies than the two we just saw, because those dependencies have other dependencies, and those are sub-dependencies. So we need a common layer to understand what our dependencies really are, and this is what SBOM is about. And we're using Trivi to extract all these dependencies and then validate those dependencies against the database to see if they have any kind of vulnerabilities, if they are fixed, if they are still open, for example. This is what we're doing here. Maybe just to give you a short overview on software bill of materials, it's basically the list of ingredients for your software. So as I mentioned, it's not about the two dependencies you saw in the code, it's about the sub-dependencies and all the multi-layer below. And without an SBOM, you currently do not have any, or can't have any idea what your dependencies really are. So it's really important to build those. In a future world, you might need only to think about your parts and you're consuming a base image, and this base image already has an SBOM and just relying on that one and adding your stuff. I think it's still the future. Currently, the best idea is to really make sure that you're doing an SBOM on all the stuff, building up on your own, and then releasing is as part of your application. And SBOM is, as I said, the baseline, either for vulnerability scanning, security parts, but also for license checks. So if you would like to make sure, if you're releasing open source, you need to make sure that the licenses are fine, for example, this could be also the baseline for that. Downside, there are currently multiple standards, so we have think a bit which tools support which standards do I need, how do I need to integrate them, though this could be a bit tricky depending on the tools, though there are multiple. Let's see how this also goes on in the future here. The most important stuff, the awareness part, is basically this here, the last one. We're publishing all the findings which are not yet fixed in our code into our pipeline directly. So if we go back to the pipeline here and go into summary, you're getting, first of all, the whole SBOM as an artifact, which you can then release with your software or doing further checks. And we're also getting a nice output here showing all the unfixed dependencies. This is, for example, there's a bash dependency which is fixed in a later Ubuntu version, but not yet part of the image, for example. We have, this is one that's fixed, but we have also a fixed ones where there's no fixed version yet. So it really depends, but we're getting all the details for our base image, in this case Ubuntu, and we're also getting here vulnerabilities for our runtime in .NET, for example. Those both were we fixed by the Docker PRs opened by Depend-about anyway. So in this case, we won't fix any of them, but in a later PR, we can then could directly fix those here as well. Yeah, I think with this, I can give to Phil.
You can merge it.
Okay, I can merge it.
If you checked all the dependencies.
You're right, let's merge it. Then you can continue with that one. Confirm. Perfect, and then you can now show the second part.
Yes.
How to fix the stuff I did not fix.
Perfect. Okay. Okay. What Nico just showed was, did we look at the Docker file? I think not. What typically we see, so we are doing consulting and we are working with a lot of customers, and typically everybody talks about best practice, use images in Docker built from scratch, but in the real world, I have to never saw it that somebody uses scratch images. So mostly you will see something like let's talk from a developer's perspective. They're using like these .NET SDK ready images from Microsoft. So they don't build their own, they just rely on this. And what comes with this is that you have always vulnerabilities in images. Yeah? So nothing is ever safe. And there's a nice tool which can help you to if you don't have the time or don't want to invest in the stuff to build images from scratch on your own, you can a nice tool which is called Copacetic. Does anybody know Copacetic? Perfect. And what Copacetic is, so this is running in the meantime. What Copacetic is doing is it takes your image, so the image has to be built, it needs to be in a registry already, so it needs to be published. At the moment, they're working on it that you can also do it on build time, but it needs to be in a registry. Then on this image, we create a vulnerability report, but let's call it tool like Trivy or whatsoever, so tool of your choice. We will pass this output to the Coppa CI tool, we apply it, and Coppa or the Coppa CI to Copacetic will create a new image, but it doesn't have to be rebuilt. It uses BuildKit to directly add this patch layer and publish the image to the registry. So there's no new build needed. So just use the existing image, run the Coppa CI tool, and you will get the patched layer. And I can, I can hopefully show it. It's still building. So what we do here is we're running the build again. So we get again the SBOM report before we patch the image. We'll get the SBOM before we patch it. Then we run our patch command. I can also show it to you in the meantime, that we don't lose time. So the nice thing about Coppa, it has also comes with a GitHub action. So we can just write a few lines of code and patch the image. So what we basically do is we're using the image, we generate a Trivy report again on this image, we will upload this artifact, we will check if there are any vulnerabilities here, then we will run the Coppa action, so we use the image what we published, we will patch it, and release a new image which has hopefully no vulnerabilities. But the thing about Copacetic is it only patches OS vulnerabilities, so nothing in your application code. You will see it when it's done. So this is the, again, I can show it to you. Here we have 49 vulnerabilities. Some are fixed, some not. Still, basically, it's the same report as Nico showed. And when our Coppa task will start, if it's pending, hopefully it will start. That's the demo effect. Maybe I can. Ah, sorry, thanks. Maybe I'm not in the right pipeline. Okay, I go again. Okay, this one is done here. Sorry. But why did I skip? Okay, we take another pipeline. Then let's take a pipeline from yesterday. This one is this here. So again, basically it's the same. We did not do anything. It's the same. We have 49 vulnerabilities. And what we now have with the new image which we released, we have 37 images, and all the which are shown as fixed are fixed now. Yeah? So we basically released the new image without rebuilding it. We patched it directly and uploaded it to our registry. That's the point of Copacetic. And what we can see here, we just named it now with the same commit hash and just add a -patched tag. So that's basically the tag. And we created a new SBOM. And what we now do to have this, what Nico explained, the full security cycle, we will patch the image with cosign. Anybody know cosign? Okay, good. And what we do here is, I can also show you the output from Copacetic. 1 second. So basically it's a CI tool, and you can see it will pull the image, directly patch it, and then we just upload it, so without building it again. So it's really fast, and yeah. And what we do with cosign is we will sign the image and also our SBOM, and so we can upload it also to our registry. What we do here, we're using the keyless signing method from Sigstore or from Cosign. They will provide a certification authority. It's called Folsio, and they will provide a record. It's a transparency lock where we can later verify the signing of our image. And with the OpenID Connect, we generate a temporary or ephemeral key and get a short-lived certificate. It's 10 minutes, I think. And with this short-lived certificate, we will sign our artifact. Here in the upper, we will sign the artifact, upload it, and the user at the end can then, with the transparency lock, because the signing event is public, everybody can see the signing event, and you can verify if the image is this what the image tries to want you to be. Yeah? And then, yeah, we can use it. And how is this working? We go back to our act. We will sign the image. I will show the code. Basically, it's also a few. We use the cosign. We will use Crane to get the right image digest. Crane is also an open source tool, I think from Google. And we will download the SBOM, which we created, so the patched SBOM. We will sign the SBOM here, test it, attach it to the image, and we will sign the OCI artifact. And what you then have is, when you go here in the registry, so we use the GitHub registry, you will see the cosign signature, the attestation, which is the SBOM, and our patched image, and the image, the other image we released before. That's basically the whole cycle. And at the end, what we did, we just write a few lines of YAML code, and we have at least from OS perspective, a secure image. There's vulnerabilities open, as you saw, 37, but this is a good start where you can have security with not a lot of effort. That's the idea. Okay, then I think we're done.
We have time for questions.
We have time for questions, yeah.
That was fast.
We also have time for stickers.
Yeah, don't forget the stickers, true. These guys always have stickers with them, so you can ask any time. Is there a question?
Many thanks for the talk. I have one question. If you drive your Rector on your own, or you use the public one?
Sorry, can you a little bit louder? I did not.
If you drive your Rector, your trust chain by yourself, or you use the public one?
We use here in this use case, we can use the public one, because that's the idea, that it's public and everybody can verify it. But you can also run your own Rico instance and your own Falsio, and you can make it, for example, on-prem in your own environment. You don't have to use the. Sorry?
You do that, or you only use the public one?
We use the public one. What you also can do, you can bring your own keys. For example, you can store it in an Azure Key Vault or AWS Key Store or HashiCorp Vault, and then you can use the signing keys for a CI and sign them with your own. So you can always use your own instance or the public one, basically.
Thank you. Are there other questions? Yes.
Oh no.
Thomas.
Oh no.
That was expected.
I have to go, sorry.
Bye, Thomas.
Yeah, sorry, I'm not a .NET expert, but I've seen there is a .NET standalone X. So this sounds to me that it is possible to create one single executable and then put it in a container from scratch, and then you don't have all these related glibc, bash vulnerabilities, and everything is much clearer. Yes. Is there a reason why you don't do it, or is it?
I think I tried to say it. Yeah, I know it, but in the real world we never see it. So that's the thing.
So you can pack it in just a binary that then basically you will get most of the stuff from the runtime as well. So it will be it's not like we're scrolling, getting a small binary, it's getting a full-blown big binary. Yeah, you get rid of all the Ubuntu stuff, of course. You get also very big layers, and if you introduce just a small change in the application, you're pulling those big layers. So it's not the fastest option. It is an option, but it's also not the option where which the developer finds directly. So the idea is here to build easy solution, give the easy starting point. You can, on every stage, improve multiple things. But yeah, it would be also an option to build a self-contained.
That would be the better option, but
yeah.
We have one question over here.
Yeah, I was wondering, where do the patches come from the capacity tool?
the patches come from from the vulnerability report. So it relies on the Trivy database, basically.
Okay,
so you have your image released, then you scan it, and then you have the report, and then Copper applies those patches where they're available.
And these patches are file system patches that are...
Yes, only OS file system patches, yes.
Yeah, thank you.
Basically in one layer in the image.
Yes.
Other questions? Oh yeah. I've been there already today. I think that's my 4th time.
Regarding Trivy SBOM, it is not that helpful regarding Trivy SBOM because I checked Trivy SBOM export stuff. That is my first question. Regarding Copacitic, it's really nice, but Trivy update its database every 3 months. If you observe Trivy, it uses in the backend NVD database. But the exploits or this stuff, it releases quite often every day. So is it possible that we can attach like OSV, like Google database, which is more, or GitHub stuff, database, which is really helpful rather than relying on just one database like NVD?
So Copacetic just relies on the report you provide. So it really depends. It's your choice, basically, which database.
Yeah, I think not every format. So you need to provide a given format to Coppa, and then it can work. Yeah. So that's what I said. Trivy just is our choice for this talk. We could also use a different tool, like Claire or something, or I don't know.
Here is next question.
Thank you guys for interesting report. Just one question.
Yep.
Is anything gets from Docker inspect after adding this layer anything interesting or just normal?
Sorry,
a little bit louder, please.
I'm asking, is there anything interesting appears after Docker inspect before and after adding this Copacetic layer?
Docker inspect? Which Docker?
I mean, anything interesting? Oh, just.
Maybe you're talking that one offline. So I'm not 100% sure.
Yeah, maybe you can talk about it later.
Let's talk in a sec.